The Big Bang. Imagine everything in existence, compressed into a single point. Not a star, not a galaxy, but the very fabric of space and time, coiled like an invisible spring, ready to burst. 13.8 billion years ago, this point expanded in a fraction of a second. It wasn't an explosion in space. It was space exploding into existence. Distances that didn't exist began to stretch faster than light itself could follow. The impact? Everything we know, atoms, stars, planets, even you watching now, is a direct descendant of that first cosmic breath, a universal genealogy, written not in blood, but in photons and subatomic particles. Few people know, but the first 3 minutes already decided the fate of the cosmos. Hydrogen, helium, a touch of lithium, the initial chemical menu that would guide billions of years of stellar evolution. The Big Bang isn't the moment it all began. It's just the further away that we can see. What was there before? Physics is silent, and that's where the boldest theories come in. The Big Bang is our flashlight in the dark, but was it really the beginning? Just wait until you hear about cosmic inflation. Inflationary theory. Think of a balloon inflating, but at such an insane rate that if you blinked, you would have already lost everything. In the first moments after the Big Bang, the universe would have grown from smaller than an atom to the size of a galaxy in less than a second. This solved a major mystery. Why does the universe appear so uniform in every direction? It's as if every corner had combined the same temperature and density before there was even enough space to talk. The impact was brutal. Without this lightning-fast expansion, galaxies might never have formed. Inflation is like the secret foundation of a building, invisible, but absolutely necessary. But here comes the twist. Some physicists say inflation never stopped, that even today, in distant places, new universes sprout like bubbles in an infinite foam. Cosmic inflation not only explains our universe, but opens the door to infinite others. What if one of them is stuck to ours, about to collide? Welcome to the multiverse. The multiverse. Imagine our universe, not as the main stage, but just a play in an infinite theater. Each cosmic bubble out there could harbor its own laws of physics, its own constants, perhaps even different versions of you. The logic is brutal. If cosmic inflation is eternal, then there isn't just one universe. There are countless others. Some with giant stars, others where gravity would be so weak that nothing would ever form. An infinite cosmic menu. Fun fact, physicist Max Tegmark divides the multiverse into levels from the simplest, just distant regions of our cosmos, to the most radical, where all mathematical reality actually exists as a universe of its own. Here's the uncomfortable detail. If there are enough universes, everything possible happens somewhere. This means that in one of these bubbles, you've already clicked on this video, but in another, you were never born. The multiverse is the greatest bet of scientific imagination. But if you think living in infinite universes is already strange, wait until you see the idea that our universe isn't even unique in time. Welcome to the Cyclical Universe. The Cyclical Universe, think of the cosmos as a beating heart. It expands, contracts, expands, contracts. Each Big Bang would be just the rebirth after a big crunch, a total collapse where everything is crushed back to a point. The importance of this idea? It eliminates the need for an absolute beginning. The universe was never born. It simply breathes eternally, in a cycle without origin or end. Fun fact, ancient cultures already imagined this. The Hindus spoke of kalpas, cycles of creation and destruction. The Greeks spoke of the eternal return. Modern science has merely exchanged myths for equations. But here's the dilemma. If the universe has experienced previous cycles, where are the traces of them? Some physicists look for traces in patterns of cosmic radiation, like scars from past universes, etched in the sky. Perhaps we are living just another act in an endless play. But not everyone believes in cycles. Some have argued that the universe has always been stable, eternal, and immutable. This was the bet of the stationary universe. The stationary universe, a bold 20th century vision. The cosmos would have no beginning or end. It has always existed, always the same. Do galaxies move apart? No problem, space simply creates new particles to fill the voids. The historical impact was enormous. Fred Hoyle, one of its greatest proponents, even coined the term Big Bang. Ironically, he found the idea of an explosive beginning absurd. To him, the universe was an eternal stage, with no opening curtain. For a time, this theory rivaled the Big Bang. After all, the notion of an unchanging universe seemed more elegant, even more comfortable. A cosmos without birth or death. But then came the fatal test, the discovery of the cosmic microwave background in 1965, a cold, invisible echo, like smoke left by an ancient fire. Clear evidence that the universe had a warm and dense beginning. The stationary universe fell, defeated by the scars of the cosmos itself. But human imagination didn't stop there. Because if the universe is neither eternal nor unique, perhaps, it is just code running somewhere. Welcome to the simulation hypothesis. The simulated universe. Imagine everything you know, galaxies, atoms, even your own thoughts, not as reality, but as lines of code running on a cosmic supercomputer. The logic is disturbing. If advanced civilizations can create perfect simulations, they would create not just one, but millions. And if there are millions of simulations for every real universe, the probability of us being on ground truth drops to almost zero. Impact? This idea brings physics and philosophy together. Even Elon Musk has stated that he believes there's a 90% chance we live in a simulation. For him, our reality is just a beta version of the digital multiverse. Few people know this, but some physicists are already searching for glitches in the matrix in the cosmos. The particle energy limit, for example, could be the pixel size of the universe. If we find this limit, it would be like seeing the edge of a screen. If we're just a simulation, who's in control? An alien mind? A future version of ourselves? We may never know. But another theory goes even further. What if the universe is just a hologram projected in 2 dimensions? The holographic universe. Imagine taking everything that exists in 3D and discovering that it's actually just a 2-dimensional projection, like a hologram on a glass plate. The idea was born from a crisis: black holes. If everything that falls into them disappears, where does the information go? The answer: it would be imprinted on the surface of the black hole's horizon, as if every square centimeter were a pixel of reality. Impact. If this holds true for black holes, it could hold true for the entire universe. What we call 3D space would be just an emergent illusion projected from a distant cosmic frontier. Fun fact: in the 1990, physicist Juan Maldacena showed how 3D universes with gravity could be equivalent to 2D universes without gravity. An almost magical mathematical correspondence, but one with real weight in theoretical physics. Perhaps we are just a shadow projected onto the backdrop of a cosmic stage. But if we are projections, what larger pattern are we part of? Some believe the answer lies in the infinite geometry of fractals, the fractal universe. Imagine enlarging a galaxy and seeing that its shape repeats itself in cosmic clusters, as if the universe were made of infinite patterns that echo at all scales. This idea was born from the mathematics of fractals, figures that repeat themselves eternally, no matter how far you zoom in. The impact is fascinating. Perhaps the entire cosmos is a self-replicating web, with symmetry hidden in every corner. Large-scale observations of the universe reveal that galaxies are not scattered randomly. They form filaments and voids, like an immense cosmic network. Some call it the web of the universe, a living fractal, shaped by gravity. And here's the almost poetic detail. If the universe is fractal, then looking at a leaf, a tree, or a cloud can be, in a way, like looking at the cosmos itself in miniature. All of nature echoes the same pattern. The fractal universe gives us the feeling that we are part of an eternal symmetry. But what if, instead of infinite patterns, our cosmos were just a lost bubble among thousands? The bubble universe. Imagine the cosmos as a boiling foam, where each bubble is a separate universe, growing, colliding, and sometimes destroying itself. When it collides,